Our story begins about 4.6 billion years ago. Imagine a vast dark cloud of gas and dust. This was the Solar Nebula, the birthplace of our solar system. It was a chaotic place filled with the remnants of dead stars. These remnants held the building blocks of planets, including our own Earth. The trigger for this cosmic creation was likely a supernova. A nearby star, much larger than our Sun, exploded in a brilliant, violent death. This explosion sent shockwaves through the Solar Nebula, compressing the gas and dust. This triggered a chain reaction, pulling more and more material inward. As the nebula collapsed, it began to spin faster and faster. The center became incredibly hot and dense. Eventually, the pressure and heat at the core became so intense that nuclear fusion ignited. A star was born, our very own Sun. The Sun's birth marked a turning point. It illuminated the surrounding nebula, revealing a swirling disk of leftover material. This disk, known as the protoplanetary disk, would become the stage for the formation of planets, moons, and other celestial bodies. The protoplanetary disk was a whirlwind of activity. Dust and gas particles, remnants from the solar nebula, orbited the newborn Sun. These particles, constantly colliding, began to stick together. This process, called accretion, marked the first step in planet formation. Within the disk, different regions experienced varying temperatures. Closer to the Sun, it was a scorching inferno. Only rocky materials like iron and silicates could withstand the heat. Further out, beyond the frost line, temperatures were much cooler. Ices made of water, methane and ammonia could also survive. This temperature gradient played a crucial role in shaping the solar system. Rocky planets like Mercury, Venus, Earth and Mars formed in the inner region. Meanwhile, gas giants like Jupiter, Saturn, Uranus and Neptune formed beyond the frost line. As these planetary embryos grew larger, their gravitational pull intensified. They attracted more and more material, clearing their orbital paths and growing into the planets we know today. This cosmic dance, a delicate balance of gravity, collisions and accretion, shaped the early solar system. The process of accretion, though seemingly simple, was a chaotic and drawn-out affair. Imagine dust grains, barely visible to the naked eye, colliding and sticking together. Over millions of years, these tiny particles coalesced into larger and larger objects. As these objects grew, their gravitational pull increased, pulling in even more material. These growing bodies, called planetesimals, ranged in size from meters to kilometers. Collisions between planetesimals were common, sometimes resulting in growth and sometimes in catastrophic destruction. The early solar system was a cosmic shooting gallery. It took millions of years of collisions and close calls for the planets to emerge from this chaotic environment. The survivors, the planets we know today, bear the scars of this violent past. For example, our own moon is thought to have formed from a giant impact. A Mars-sized object slammed into the early Earth, ejecting a massive amount of debris into space. This debris eventually coalesced to form our moon. These impacts, though destructive, were also crucial in shaping the planets and their moons. About 4.5 billion years ago, Earth was a very different place than the one we know today. It was a hellish world, covered in a magma ocean and bombarded by asteroids and comets. This period, known as the Hadean Eon, was a time of intense heat, volcanic activity and constant upheaval. The young Earth was still cooling down from its formation. The heat from radioactive decay within its core, combined with the energy from constant impacts, kept the surface molten. Volcanoes erupted violently, spewing lava and gases into the atmosphere. The atmosphere was thick and toxic, composed mostly of nitrogen, carbon dioxide and water vapor. There was no free oxygen, and the surface temperature was scorching hot. Oceans, as we know them, did not exist. Instead, any water present would have evaporated instantly. Despite these harsh conditions, the building blocks of life were beginning to assemble. Organic molecules, the precursors to life, were likely delivered to Earth by comets and asteroids. These molecules, protected from the harsh radiation of space, found a foothold in this primordial soup.